All right, let's solve some more trigonometric equations. All right, so here we have an equation cosine of pi over 2 times the quantity t minus 1 is equal to a negative square root 2 over 2. And we want all of the solutions between negative 3 and 9. All right, well, let's think this through a little bit before we get started. You can see that this is a horizontal shift, right? This is a horizontal shift. Okay, so it's being shifted to the right by 1. All right, this is our b value, right? B value, this is our, and the period, I can use that to find the period, right? This is gives us the period is equal to 2 pi over b, which in this case b is pi over 2. Okay, so I get a period of 4. Okay, so that's our period, 4. So, so that just kind of gives us an idea of what this equation looks like. But really what we need to do is find out what values have a cosine of negative square root 2 over 2. So I'm just going to start by drawing a unit circle, or you may be just pulling out your unit circle and looking it up. Okay, so negative, the cosine is negative. Okay, so we're over in the left, on the left-hand side here. Square root 2 over 2. All right, so we have an angle here. Oops. Right, and then we'll have another angle down here that has that same cosine value of negative square root 2 over 2. And you can see that this is going to be 3 pi over 4. And this one down here is going to be 5 pi over 4 down here. Okay, so what we know then is that pi over 2 times t minus 1, that's our input to the cosine, has to be equal to 3 pi over 4 plus 2 pi n, right? Because we'll get another solution every time we go around the circle. Or we have the other case where pi over 2 times t minus 1 is equal to 5 pi over 4 plus 2 pi n. Okay? So that essentially gives us all of the solutions, but we have to do a little bit of algebra then to actually figure out what t is. All right? So the values we get from the unit circle are the values for the input to cosine, and now we have to do a little algebra. All right, well, let's first of all, let's see, we should divide both sides by pi over 2, which is really the same as multiplying by 2 over pi. So I end up with t minus 1 is equal to, I'll just write it out, 2 over pi times 3 pi over 4 plus 2 pi n. Okay, and so let's just work with this one first. If I multiply through, I will end up with, it looks like I get 3 halves plus 4n. Okay, that's what t minus 1 is. T minus 1. So then I have to add 1 to both sides. So t is equal to 1 plus 3 halves is 5 halves, but I could write it as 2.5 plus 4n. All right, so there's my solutions for the angle that's at 3 pi over 4. Okay, for all the solutions. Now I have this other solution here, and so I can just do the same thing. I get t minus 1 is equal to, I'm just going to again multiply by the reciprocal, 2 over pi times 5 pi over 4 plus 2 pi n. Okay, and then distribute that, I get t minus 1 is equal to, let's see, multiply that, let's see, that's going to be 5 halves plus 4n. Okay, and then I'm going to add 1 to both sides. So t is equal to, so that's 2 halves plus 5 halves gives me 7 halves. So I'm just going to write that as 3.5 plus 4n. All right, so now I have my I have my two sets of solutions, and now I want to figure out all of the values between -3 and 9. All right, well, let me set up a little table here. So I'm just going to put in some values of n, and I'm going to calculate really the two sets of values for theta, right? I have values related to, I've got two solutions really, and I'm just going to write them separately. All right, well, the period is 4, right? So if and it's shifted to the right by 1, so really 3 is the end of my end of the kind of the -1 period. But so I think I need 1 period back, and I need 2 periods forward. But we can just look at the values we get, and just if we get values that are beyond the interval we're looking for, we just cross them out. All right, so now the 0 one is easy, right? Because I'm just going to have values at 2.5 and 3.5 when n is equal to 0. Right? Now when n is equal to -1, I'm just going to subtract 4 from 2.5, and I get, what's that, -1.5. If I subtract 4 from 3.5, I get negative 0.5. Okay? And then I can go 1 period forward. Now if I go back by more, it'd just be subtracting 4, which would take me, I'd just be subtracting another 4 from the period I just got. And so that would take me too far back. All right, let's go forward by a period. All right, so let's n equal 1. So if n equals 1, here I get 6.5. And if n equals 1 here, then I get 7.5. If I add any more 4s to either one of those, I'm going to be beyond 9. So that's all I need. So these are my solutions here in this table. Those are all of the theta values. Or not theta, I guess I guess I use theta. I guess I'm using, but in this case it was actually t, wasn't it? So I guess I should write t. These are my t values that give me a solution to this equation. Okay, these are all the t values that satisfy this equation on the interval between -3 and 9. All right, I'll meet you in the next video.